Bismillahirrahmanirrahim. Today our lab is Introduction to ModelSim and Quartus 2. So the objectives of our today lab is to have an interactive introduction with ModelSim, to make students familiar with Verilog HDL and to understand gate level modeling in Verilog HDL. First of all, we have to know that what is Verilog HDL. A hardware descriptive language (HDL) is a computer-based language that describes the hardware of digital systems in a textual form. It resembles an ordinary computer programming language such as C++, but is specifically oriented to describing hardware structures and the behavior of logic circuits. So, HDLs are used in several major steps in the design flow of an integrated circuit, that are design entry, functional simulation or verification, logic synthesis, timing verification, and fault simulation. So basically, Verilog HDL is a language through which we can implement any logic circuit or any practical circuit or any boolean functions into software language. We can represent any practical circuit by using this language and we can implement it on Quartus 2 software. So now we see what are the basic operators in the Verilog HDL language for the AND gate, OR gate, NOT gate and so on. So here you see in this picture the basic operators of Verilog HDL. The operators of AND gate, the operators of OR, XOR, NOT, equality, greater than and less than. So this is our Verilog HDL language, and now we are going to use the Quartus 2 software. Here I am starting the Quartus 2 application. Here create a new project, click next. This is the directory where this project safe, and now I am going to give the name to our project. Next, click next. Here you see in the device family I am going to select the Cyclone 2 because I am using the Quartus 2 software. Now in available devices I am going to select this AP2C20F484C7. Now click next, again next, and now finish this software. Now this screen appears. Here you have to select the Verilog HDL. Now click OK, and finally this screen appears where you have to write the code of any circuit. After creating the new project, I have written the code of our lab. Today I am going to implement the basic logic gates, Boolean expression and De Morgan's law. So I have written this code. Our module name is Hannan, and these all are the inputs and outputs of our program. Now I have written the inputs. I have 4 inputs A, B, C and D, and these are the outputs X, Y, A, F, G, H for all the gates, Boolean expression and De Morgan's law. After that I am going to assign the logic gates. Here you see the assign is operator to assign any function. Here on the left hand side you see the output, and on the right hand side you see the function which I am going to implement. So I have implement all these gates, which are AND gate, OR gate, NAND gate, NOT gate, NOR gate and XOR gate. After this I have written the code for the Boolean expressions for the F1 and F2, which is F1 is A complement into B plus C complement into D, and the expression for the F2 is A complement into B complement plus C complement into D complement. So you see that I have written the code for any circuit by using simple operators. After that, I am going to implement the De Morgan's law. For first case of De Morgan's law is a plus b whole complement equals to a complement dot b complement. And similarly, second case of De Morgan's law is a dot b whole complement equals to a complement plus b complement. Here you see I have implemented the right hand side of our first case, which is a plus b whole complement. And here you see I have assigned the left hand side of our first case, which is a complement dot b complement. And similarly I have assigned the right hand side and left hand side of our case 2, and at the end module is for to end the program. After writing the code completely, we have to start compilation. We can start compilation by using this option and by using Ctrl plus L also. Now the compilation is running. Here if any error occurs, then you have to correct your program to see that there is no error in our program. You see our compilation was successful, no error occurred. Now click OK. Now we have to create the new. Here I am going to select now University Program VWF. Then click OK. Here you see the waveform screen appears. Here you have to get edit, insert and insert node. Here I am going to select the node finder. Now click list. Here all the input and output waveforms appear. Because we have to select all these, so I am going to click these double arrows. Here you see on the right hand side I have selected all the inputs and outputs. Now click OK. OK, and here you see our all inputs and outputs appear. To give the time period input A, I am going to select input A. Now this option, and here I am giving the period of 50 to input A. Now to input B I am giving the time period 100. You see that I am giving the time period double to input of that previous input. This is our concept that this is done. Now after that I have to run this simulation. Now run this simulation waveform. I have to save my changes, so I have to click yes. Save this waveform, and now simulation is starting. If there is any error in your input and output, so this waveform will not occur, because I have no error in my program. So finally this is our output waveforms. These are the left hand side, right hand sides of De Morgan's law. These are the inputs and these are the basic logic gates and boolean expressions of our waveforms. So after seeing these waveforms, you can verify your circuit very easily. So you can see that by using the Quartus 2 software, we can implement any boolean expression or any logic circuit or any digital circuit by using HDL language into Quartus 2 software, and after that we can check our circuit whether it is right or wrong. Here you see, and by these options you can view the RTL viewer of your circuit. This is basically the circuit that I have implemented in HDL language. So that's enough for today's lab. In today's lab we see how we can use the Quartus 2 software, how to write the HDL language in Quartus 2 software, and after that we can check the output waveforms of our circuit and check that whether our circuit is right or wrong. So at the end, that's all for today's lab. Take care. Khuda Hafiz.